discuss one of the basic law in electronics, which is Kirchhoff law. What is Kirchhoff law? We know that Ohm's law, which relates voltage, current and resistance in a circuit. It is a fundamental principle, right? Similarly, Kirchhoff law also describes the relationship between voltage and current in an electric circuit. So, what is the difference between these two laws and why we need to learn Kirchhoff law? Because in case of a complex circuit means the circuit which is having a voltage source or a passive component like resistor, capacitor, inductor, etc., which is connected in a series or parallel combination. So it's a complex circuit. If you want to solve or simplify a complex circuit, if you are using a simple Ohm's law, it is not able to or it is not possible to solve a complex circuit. So if you want to solve a complex circuit or simplify a complex circuit, we need to use some other laws. For example, mesh analysis, nodal analysis, and Kirchhoff law. So, in this video, we will learn about Kirchhoff law. German physicist Gustav Robert Kirchhoff developed Kirchhoff law. He introduced two fundamental rules. First one is Kirchhoff current law or KCL. Second one is Kirchhoff voltage law or KVL. KCL deals with the current flowing through a closed path. Similarly, KVL deals with the voltage source in a closed path. Before going deeper about these two, we have to know or we have to learn some basic terms in electronics. First one, circuit. You are familiar with this word, right? So what is circuit? Circuit means it's a closed path through which current is flowing. So, I will draw one circuit. We have a voltage source and I am connecting to a resistor, one more resistor, one more voltage source. Here also I am connecting one resistor. I am connecting here. So this is a circuit. The second one is node. Node is nothing but it's a point in a circuit where two or more circuit elements meeting or two or more circuit elements are connected. So if you are checking here, I am going to name this voltage source as V1, voltage source V2, resistor R1, R2, R3 respectively. So here, if you are checking the voltage source V1 and resistor R1 is meeting at this point. So these are the circuit elements, right? The voltage source and the resistors are the circuit elements. So this point is a node. I am giving the name as A. So A is a node. Similarly, if you are checking here three resistors are meeting at this point. So I am naming this as B. B is also a node. If you are checking here, resistor R2 and voltage source V2 is connecting at this point. I am naming this point as C. C is also a node. And if you are checking here, both the voltage source and the resistor R3 is meeting at this point. I am naming this point as D. So D is also a node. If two or more circuit elements meeting at any point, we will name as node. Third one, junction, which is similar with node. Here, three or more circuit elements meeting or connecting point is called junction. So if you are checking in this circuit, here you can see three elements, circuit elements are connecting at this point. So we can say B is a junction. Similarly, if you are checking D, R3, V1 and V2 are meeting at this point. So three elements are meeting or connecting at this point. So D is also a junction. So we can say every junction is a node, but every node is not a junction. Fourth one, loop. Loop is nothing but a closed path. So if you are checking this diagram, we can say A, B, D, it's a closed path, right? So A, B, D is a loop. Or if you are checking here, B, C, D, this is also a closed path. And A, C, D, or we can say A, B, C, D, it's a closed path. So these are the loops. Fifth one, mesh. Mesh means it is the simplest loop. So which cannot be further divided. So if you are checking here, A, B, C, D is a loop, but it's not a simple one or a smallest one. So if you are checking A, B, D, it's a small one and it cannot be further divided. So it's a mesh, this path. This is a mesh. Similarly here also B, C, D, it's also a mesh. We cannot further divide it. So B, C, D also mesh. Sixth one, branch. Branch means it's a path between two nodes. So if you are checking here, there is a path between A to B. So it's a branch, this path. Similarly, B to C we have another branch. C to D, another branch. Similarly, A to D also a branch. So here a circuit element also there and two nodes also there. So the path between two nodes, it's a branch. So these are the basic terms which you have to know. Let's discuss about Kirchhoff current law. Kirchhoff current law, which is also known as Kirchhoff first law or Kirchhoff junction law. For example, consider this as water tank filled with water and we are connecting it into two taps through a hose pipe. So if we are pumping water through this portion, water will start flowing from both the taps, right? So the total water pumping through this part is equal to the amount of water flowing from these two taps. So, Kirchhoff current laws saying the same thing. If you are considering a node N, suppose I1 current is entering to this node, I2 also entering, current I3 is entering this node, current I4 leaving from the node, similarly current I5 also leaving from the node. So Kirchhoff current law saying that the total current entering to the node or junction, the total current entering to the node, to a node or junction is equal to the total current leaving from the node. Or we can say the algebraic sum of current at any node. So algebraic sum of current at any node is equal to 0. So here I1, I2, I3 are the current which is enter into the node. Similarly, I4 and I5 are the currents which is leaving from the node. According to current convention or sign convention, whenever a current entering to the node, we will consider as a positive current. So these three currents will be positive current, while the current leaving from the node we consider as negative current. So I4, I5 will be the negative current. So according to KCL, we can write I1 plus I2 plus I3, the total current entering to the node is equal to the total current I4 plus I5, the total current leaving from the node. We can write this equation as I1 plus I2 plus I3 minus I4 minus I5 equal to 0, which means the sum of current in the node is equal to 0. We can say current in terms of charge, which means I equal to Q by T. That is the rate at which the charge is flowing. So we can rewrite this equation 1 as, equation 1 become Q1 by T plus Q2 by T plus Q3 by T equal to Q4 by T plus Q5 by T. We can simplify this in terms of charge as Q1 plus Q2 plus Q3 equal to Q4 plus Q5, which means the charge entering to the node is equal to the charge leaving or coming out of the node. So we can say that the KCL is nothing but law of conservation of electric charge. So which is very important. For example, here we have a circuit which contains three nodes A, B and C, and current I1 to I6 are the current which is flowing through the circuit. I1 equal to 2 amperes I4 equal to minus 1 ampere, I5 equal to minus 4 amperes. These are the given currents. We have to find I6 current which is entering to node B. So to find I6, we need to apply KCL at node B. So let's apply KCL at node B. In node B, we know that I3 and I6 are the entering currents to this node. Similarly, I1 is the leaving current from the node B. So by applying KCL, we can write I3 plus I6 entering current which is equal to the leaving current I1. So from this equation, I3 plus I6, we know the value of I1 which is 2 amperes. So from this equation we can write I6 equal to 2 amperes minus I3 which is equation 1. So to find I6 we have to find I3 now. To find the current I3 we have to apply KCL on node C. So in node C, if you are checking node C, I5 and one more current is there, I2. These are the two currents which is entering to the node. Similarly, I3 is the current which is leaving from the node. So we can say, applying KCL at node C, I5 plus I2 is equal to I3. So we know the value of I5 minus 4 plus I2 equal to I3. From this equation we can write I3 is equal to I2 minus 4 which is equation 2. Now to find I3 we have to find I2 current. To find I2 current we have to apply KCL on which node? Node A. We know that in node A, I1 and I4 are the two currents entering to the node A and I2 is the leaving current. So by applying KCL on node A, we can write the equation as I1 plus I4 equal to I2. We know the values of I1 and I4, right? So we have to apply here, which means 2 plus minus 1 equal to I2. 1 ampere equal to I2. So we got the value of I2. So we have to put the value of I2 in equation 2. Then I3 becomes 1 minus 4, which means we'll get I3 as minus 3 ampere. So this value of I3 we have to apply in equation 1. So equation 1 becomes I6 is equal to 2 ampere minus 3 ampere. So 2 ampere plus 3 ampere which is 5 ampere. So 5 ampere is the current which is entering to the node B. In this way, by using KCL, you can find the current in any circuit. The KCL helps to ensure that the current is distributed appropriately in a circuit or not. By applying the node at each node, the designer can identify how much the current flow through different branches of circuit. Similarly, how we are calculated the current in each node, we can find out how much the current is flowing through each branch of the circuit. So this is crucial for optimizing the performance as well as efficiency of the circuit. So KCL is one of the important rule or important law in electronics.